Solve the following equations for x is an element of 0 to 2 pi for, I'm doing b this time, cos x equals sin x on 2. So this one's going to take a little bit of work, and certainly you'll need your double angles again. Equals sin x on 2. So start with the one you know. Obviously, if we're going to have coses and sines, we're going to need the cos 2x double angle here. So cos 2x equals equals 1 minus 2 sine squared x. So that's just the standard formula. So if we halve all the angles, we'll get cos x is equal to 1 minus 2 sine squared x on 2. Okay, so that's a little bit nicer. All right, so where does that actually lead? So what we can do is, if we go with our b, if we sub in for our cos x, then we'll have 1 minus 2 sine squared x on 2. Okay, that will be equal to sine x on 2. So that's okay. So now what we're going to do is make that a quadratic. So move everything to the, I'm going to move to the right hand side to make things positive. So I'll have 2 sine squared x on 2 minus sine x on 2, plus sine x on 2, because that didn't move, minus 1 will equal 0. Now that's a quadratic, so we can factorise that into 2 sine x on 2. It's either going to be plus 1 or minus 1, so it's a positive in the middle. So I think you'll find that'll be minus 1, and the other one will be sine x on 2 plus 1. So that means when you multiply the 1 by the 2 sine x on 2, that's going to give you the positive answer. And of course that equals 0. So either bracket equals 0, so we now have 2 sine x on 2 minus 1 equals 0, or sine x on 2 plus 1 equals 0. Solving that will give us sine x on 2 equals a half, or sine x on 2 equals minus 1. So again, check your domain. Because x is between 0 and 2 pi, but we're only dealing with x on 2, x on 2 will be an element of just half both of them, 0 to pi. That just makes life easier. So x on 2 equals sine to the minus 1 of a half. So x on 2, sine to the minus 1 of a half is pi on 6. Now, if you're not sure, that's okay. Then put in more answers than you need. So if I put in, the next time sine's positive is in the second quadrant, so that's 5 pi on 6. Then when you multiply it, x is equal to 2 pi on 6, which is pi on 3, or 2 times 5 pi on 6 is, because that was within our domain, is 10 pi on 6 or 5 pi on 3. And see, both those answers are clearly within the domain. If you'd gone any bigger than that, if we'd put another value in, so we'd added 2 pi and got, instead of pi on 6, add 2 pi, got 7 pi on 6, when you doubled that, then you would get 14 pi on 6, which is bigger than 2 pi, so it wouldn't be in the domain. And the other part is when is sine x on 2 equal to negative 1? So just use your trig graphs for that, and x on 2 is going to occur at 3 pi on 2. And again, if you add 2 pi or subtract 2 pi, that'll be out of the domain. So x will equal 3 pi on 4. So your solutions are x is equal to pi on 3, 3 pi on 4, or 5 pi on 3. It's a beautiful thing.